Looking for soul opens a new unexplored door. Tune in and soar with us, let's flow. Discover the unknown, see where we go.
Welcome back to the Deep Dive. You know that feeling when you see a cutting-edge benchmark, maybe something like the poetic ARC AGI results, and you just get this spurt?
Yeah. It's that gap you see between the raw potential and, a truly robust operation. The models are clearly smart, but the answers can be brittle.
Brittle, exactly. And that's really where the whole project we're diving into today began for you. It started with a very practical question, right?
Totally pragmatic. It was. How do we get a cluster of these smaller, expert-leaning open source models running on limited hardware, maybe just a single consumer GPU?
Or even just a CPU.
Right, or just a CPU, and have them produce a better, more reasoned, and just a more complete answer than any one of those models could give on its own.
And that initial architecture, the first pass, that took you about 4 hours to really map out.
Yeah, that was all about utility, just creating what you might call cognitive diversity to, find the blind spots. But then it started to evolve pretty quickly.
It had to, because once the system started giving you these incredibly nuanced, high-value answers, the whole architecture needed to change. The mission shifted.
It did. It went from just better answers to something, much more foundational, something that could actually survive a hostile inquiry.
And that was the next 6 hours of work, right? Hardening that initial concept into what you're calling a governance reasoning layer, or a GRL.
Exactly. The challenge became, okay, how do we make this thing auditable? How do we make it accountable, ethically robust, and ready for, high-stakes domains, banking, regulatory compliance, that kind of thing?
So that's our mission today. We're going to unpack that whole journey, and we'll start with the engine itself, the deliberative core. I love this idea of engineering dissent as a feature, not a bug.
Yeah, let's get into that. Because I think a lot of people's first instinct is to just, ask 5 different models the same question and, take the average.
Right, some kind of simple consensus.
But the sources are so clear on this. Simple consensus fails. It almost always collapses into just a kind of polished redundancy.
And that's worse than useless. If all the models agree on the wrong thing, you haven't actually bought yourself any safety at all.
Precisely. The real value here comes from 3 specific things working together. You need diversity of inductive bias, which just means they fail differently.
Right.
You need structured interaction. They can't just chat. And finally, you need synthesis, a mechanism that actually preserves the conflict. Without that structure, you've just built a really eloquent echo chamber.
So it isn't about having 5 banking experts. It's about having 5 different ways of thinking about a banking problem.
That's it. And the roles you laid out are designed to create that friction, that institutional dissent. First up, you've got the core generalist.
And this is so key. This model never sees the original question.
Never. Its only role is as the arbiter. It weighs the written testimony from the other 4. It's a neutral judge, biased only by the evidence it's presented.
That's a huge insight right there. You're preventing the final judge from being polluted by the initial framing of the question.
Absolutely fundamental. Then you have the specialized views. You need a technical systems thinker. This one's focused purely on logic, on procedure, on numbers. It's the literalist in the room.
And you balance that very literal view with the philosophical ethical thinker.
Right, the one whose job is to surface hidden assumptions, to reframe the entire challenge. It's the one that asks, wait a second, are we even asking the right question here?
Then you have the planner long horizon thinker.
Yep. Its sole job is to map out the multi-step consequences, the second and third order effects, the long-term strategic risks of any action.
And my personal favorite, the wildcard sanity check.
Ah, yes. And it's deliberately a smaller, faster model. Not for efficiency, but for cognitive diversity.
It's the cognitive tripwire.
Exactly. It's not supposed to be the deepest thinker. It's supposed to be the fastest to spot a simple contradiction that the bigger, more complex models might have just smoothed over.
So you have the ensemble, but the workflow is where the magic really happens. This is a deliberation, not a group chat.
And it has to be phased. So phase 1 is independent framing.
Each model answers totally alone.
In isolation, yeah, but with a strict role constraint. Identify risks or propose unconventional perspectives. This guarantees you start with divergent views. You avoid that early convergence.
Then you hit phase 2, cross-critique. And this is where the real value gets generated. But wait, why do the models only see summaries of what the others said? Aren't you losing detail there?
That's a great question, and it's a very deliberate design choice. If you give them the full 1,000-word response from another model, the critique often gets bogged down in, like, stylistic things, tone, phrasing.
Ah, okay.
By forcing them to critique a tight summary, you compel them to focus only on the core logic, on the findings. It ensures the critique is about overlooked assumptions, not overlooked adjectives.
That makes a lot of sense. The dissent has to be about the architecture of the argument, not the articulation.
Exactly. And that dissent is the safety mechanism we're building.
Mm-hmm.
Which brings us to phase 3, arbiter synthesis. The generalist model finally comes in to reconcile all these conflicting views.
And here's another brilliant constraint you built in. The arbiter is actively penalized if it tries to just collapse everything into one nice, neat answer.
It has to produce 3 distinct options. You've labeled them conservative, balanced, and bold. If it tries to smooth out all the conflict and just present a single path forward, that's a procedural failure. The system has to show the full spectrum of risk.
That institutionalization of dissent, of uncertainty, it's the perfect bridge to our second section, accountability. You've moved from just getting a better answer to building a governance-grade tool.
And for that to work, the system has to be honest about its own limits. It has to know when it does not know.
So the architecture shifts to actually detecting its own internal conflict. Signal 1 is the disagreement scoring.
Right. And you suggested a really simple, auditable way to do this. You just count specific contradiction markers that the models use in that critique phase. Words like overlooked, disagree, assumes incorrectly.
And that gets normalized to a score from 0 to 1. But, I mean, is that really robust enough? Couldn't a clever prompt or model learn to argue without using those exact keywords?
That's a fair challenge. And look, it's a trade-off. You're sacrificing some machine learning complexity for something that is just unquestionably auditable. A human regulator can look at it and understand it instantly. There's no black box. If the models are debating properly, that score goes up. Simple as that.
And that score is what drives Signal 2, escalation logic.
If the disagreement score crosses a certain threshold, say 0.4 or 0, or if the initial prompt contains high-risk keywords like regulatory or financial, it triggers an escalation.
It's like a circuit breaker.
It is. It forces the system into a conservative interpretation, and, critically, it flags the whole thing for a structured human review.
Which brings us to the human-in-the-loop protocol, because you raised this concern. What about bad human input? You know, an overworked analyst just clicking approve to get it off their desk.
That rubber stamp is worse than useless. So this isn't just feedback. It's a formal, structured intervention.
A commitment, not just an option.
Precisely. To proceed after an escalation, the human can't just click a button. They have to formally acknowledge the risk, they have to engage explicitly with the notarized minority view, and they have to declare their stance like, proceed with constraints, and then, crucially, accept formal personal accountability.
And this is the part of the architecture I find most powerful. If the human gives a lazy, half-hearted input,
The system stops.
it just blocks all automation and progression.
That friction is a feature. If the human won't commit, the machine will not proceed. And every single bit of this is captured in a tamper-evident audit record, notarized with a cryptographic hash. The inputs, the outputs, the disagreement score, the human's decision, everything.
Let's double-click on that notarized minority view. We're not just throwing away the dissenting opinions here.
No, absolutely not. You have to think of it like a formal dissenting opinion from a Supreme Court justice. It gets recorded, it gets contextualized, but it's not adopted by default.
So if the decision the human makes ends up being wrong 6 months down the line,
The audit trail proves exactly what risks the system knew it was taking. You can trace what it was potentially overlooking. That traceability is everything for legal and regulatory defensibility.
and that defensibility, that's what elevates this whole thing from just a clever tool to really necessary infrastructure. Which brings us perfectly to Section 3, constitutional AI.
Right. This is the big insight. The architecture transforms that little cluster of models from a tool into a permanent governance reasoning layer. And to work like infrastructure, it needs a separation of powers.
Which is the division between the kernel and the domain profiles.
Think of the kernel like a constitution. It sets the fundamental laws. It's the immutable core that enforces things like authority, auditability, and the safety rules. The kernel has no idea about domain content. It doesn't know about banking rules. It only enforces how reasoning has to happen safely.
So the kernel has the authority, the ethics, but the actual knowledge is in the plugins, the domain profile.
Correct. The domain profiles are just specifications. Think of them like JSON objects. They codify the procedural knowledge for a specific sector, legal, medical, whatever. They hold the knowledge, but the kernel alone holds the authority.
I think this concept of governance by refusal is so powerful, defining what the system won't do before you even define what it can do.
And what's so interesting is that the non-goals you defined forbid the system from doing things LLMs are actually very good at. For example, the system shall not optimize for speed or cost.
Why would you forbid optimization?
Because in high-stakes governance, safety requires friction. It requires deliberation. Speed is actually an anti-goal when accuracy and accountability are your mission. Likewise, it shall not perform clinical decision-making. And maybe most importantly, it shall not engage in moral substitution or creative policy interpretation. It has to stick to the defined procedure.
And if a human tries to push it to do one of those things,
The kernel enforces a procedural refusal. It says no, and it records that refusal in the audit log. And if that's not enough, there's the final backstop, the Universal Domain Admissibility Checklist.
pre-deployment veto.
Exactly. The system is disallowed entirely if certain hard criteria fail. For instance, if the domain lacks identifiable human authority, if it's being used for some informal anonymous process.
Or if it can't tolerate a no.
Right. If the domain cannot tolerate refusal, cannot handle an I don't know response, the GRL refuses the assignment.
So if you, the listener, tried to use this for something like, I don't know, personal fashion advice where there's no real accountability.
Kernel would just say no. Precisely. The governance reasoning layer enforces that you can only apply governance to domains that are fundamentally governable, where a human can ultimately be held accountable.
So wrapping this up, what does this all mean for you? We started with this idea for a local LLM cluster to get a better answer, and you ended up designing a general-purpose constitutional AI framework. You've built a system that institutionalizes dissent, makes risk visible, and forces human accountability.
And if we really connect this to the bigger picture, this GRL is designed to survive a hostile inquiry, a parliamentary investigation, a regulator. Why? Because it can prove with its audit trail that it resisted overreach, that it preserved uncertainty with that minority view, and that the human always remained the accountable executive.
That is the very definition of governance-grade infrastructure. We went from, seeking computational efficiency to building constitutional constraint on the act of reasoning itself.
We did. So I guess the final provocative thought for you to take away is this. What domain out there right now is suffering from vague accountability and systemic procedural failure?
Things like algorithmic oversight, maybe public inquiries.
Or even complex electoral process administration. Which of those domains is ready to adopt a system that prioritizes auditability and provable restraint over the simple convenience of speed?
That's the real-world application of this entire framework, and that's a deep dive we will definitely have to continue.